So we're going to use a reference angle that's in radians to find the sine and cosine in this question. So the first thing we have to do is convert negative 5 pi over 6 to degrees. I showed you how to do this in an earlier video, and there is a shortcut, but I'll remind you of the normal way first. So I'm going to take negative 5 pi over 6, which is in radians, and I'm going to multiply by 1. Now, my 1 has to cancel out the pi. I want to convert this to degrees. So what I know, my 1, it's going to be a funny looking one, is that pi radians is equal to 180 degrees. Since those two are equal, 180 and pi radians, it's a funny version of 1. I'm multiplying negative 5 pi over 6 times 1, and when I simplify it, it will now be in degrees. So the pi's cancel, and 5 times 180 divided by 6 is 150, so this is negative 150 degrees. Now remember, negative angles go this direction, and positive angles that direction. So positive is counterclockwise, negative is clockwise. That's the way it works. So I'm going to go 150 degrees in the negative direction. So I'll keep going around in standard position, and 150 degrees, when I do that, there's going to be a reference angle of 30 degrees. Remember, the reference angle is always between the x-axis and the terminal side. So now we bring out our ratios in our 30, 60, 90. And between the 90 and the 30 is the root 3. And because of where it is in the coordinate plane, this is a negative root 3. Between the 60 and the 90 is the 1, and that's a negative 1. And the hypotenuse is 2. The hypotenuse is always going to be positive there as we go around. So we're going to find the sine and cosine now. The sine of negative 150 degrees, which is negative 5 pi over 6. If you were to punch that in the calculator, you have to put it in radian mode. It's the same thing as the sine of negative 150 degrees. And sine is opposite over hypotenuse. So opposite or reference angle is negative 1. And the hypotenuse is 2. The cosine of negative 5 pi over 6 is adjacent over hypotenuse, so we're looking at a reference angle now, which is 30 degrees. Adjacent to it is negative root 3, and the hypotenuse is 2. Another example of finding sine and cosine using our reference angle in radians, another negative angle, negative 4 pi over 3. First thing we're going to do is convert that to degrees, so we know what that is. And negative 4 pi divided by 3, we're going to convert that, and we need that pi to go away because it's in radians, and I want to make it degrees. Again, I know pi radians is equal to 180 degrees. Again, this is a funny 1 because 180 degrees and pi radians are the same thing. Anything divided by itself is 1. I want to work that out. The pi's cancel. And 4 times 180 divided by 3 is 240. So it's negative 240 degrees. Now, I mentioned before, if you caught it, that there is kind of a shortcut here. Another way to convert this works when you have radians to degrees, is you can substitute. You can say that negative 4 pi, remember what pi radians is, it's 180 degrees. Those two are equal, they're the same thing. So I could just plug in 180 degrees for that pi, and divide it by 3, and that will also get me negative 240 degrees. Now I'm going to draw my angle in standard position. I'm going in the negative direction. I'll go negative 180, and I got to go 60 more. So my reference angle is right there. It's 60 degrees, and we'll draw our 30, 60, 90. Between the 90 and the 30 is the root 3. In this case, the root 3 is positive in quadrant 2. Between the 60 and the 90 is 1, but because of where it is on the x-axis, that's a negative 1. And the hypotenuse of our 30, 60, 90 is always 2, and then the hypotenuse is always positive as we go around in standard position. And now we can find the sine and cosine. So the sine of negative 4 pi over 3 in radians is opposite over hypotenuse, and our reference angle again is 60, and the opposite is root 3 over the hypotenuse of 2. The cosine of negative 4 pi over 3, cosine is adjacent over hypotenuse, and the adjacent to our reference angle is negative 1. That makes the cosine negative 1 adjacent over hypotenuse 2. So the cosine of negative 4 pi over 3 radians is negative 1/2. Last example, 7 pi over 4. We need to convert that to degrees. 7 pi over 4. I'm going to use the substitution method here. I know that pi radians is 180 degrees, so it's 7 times 180 divided by 4. And 7 times 180 divided by 4 is 315 degrees. So I'm going to go around 180 to 70. And let's see, that would be 45 more, 45 degrees more. So our reference angle is always between the x-axis and the terminal side, and it looks like it's 45 degrees. Let's see, 360 minus 45 is 315, yes. And this is a 45, 45, 90. And the sides of 45, 45, 90 are 1, 1, and root 2. Now look where these numbers are. The one going down here is going to have to be a negative 1. Use my negative in there because it's below the x-axis. So now we can find the sine and cosine. Here goes. The sine of 7 pi over 4. Use our reference angle. Sine is opposite over hypotenuse. So that is negative 1 over root 2, which will rationalize. This ends up being negative root 2 over 2. The cosine of 7 pi over 4. Cosine is adjacent over hypotenuse, and our reference angle is 45. The adjacent is 1. That's 1 over root 2, which again will rationalize. And that ends up being root 2 over 2.